Assalamualaikum warahmatullahi wabarakatuh. Okay, this would be another video on the volume for cylindrical shells method. Okay, right now is for the cross section parallel to the x-axis. Okay, for this one, we let f and g be continuous functions on the interval c to d, and let r be the region that bounded by the functions of x equal to fy, x equal to gy, and the lines y equal to c and y equal to d. Therefore, the volume V would be equal to circumference times the height times the thickness, which is 2 pi ry multiplied with the cy and delta y. Okay. Hence, volume of the solid that is generated by revolving the region R about the x-axis or the line y equal to A, okay, is given by V equal to integrate from C to D 2 pi ry cy with respect to y, where r here is the distance between the shaded region to and from the axis of revolution. That means here is the axis of revolution. As you can see, this is the axis of revolution. Okay, sorry for the crooked line. Okay, that means here r. If we drag here to here, this would be the r. Okay, and the cy is the height of the cylinder. This is the height from end of the shaded region to the other end of the shaded region. This is the H. Okay, and this will be the example of all the cylinders that will be in this figure. Okay, that means the image of this figure is actually this one. Okay, for this one, this will be the cylinder. Okay, that means this is the accumulation of all the cylinders inside the shaded region. Okay, this is the slimmest, one of the slimmest cylinder then in here. Until this one, this is the biggest cylinder then, that has the biggest R. Okay, and here is the image which can be interpreted by this cross section. Okay. Now let's look at an example. Okay, determine the volume of the solid obtained by revolving the region R about the line x-axis using the shell method. So it will be revolved here. Okay. Since it is shell method, we need to have R and H. Okay. Right from the axis of rotation to the nearest edge of the region bounded, this would be your radius. Okay. And from the end of the shaded region to the other end of the shaded region, this would be your H. Okay. So for this figure, H is horizontal. Therefore, V is equal to 2 pi integrate RH with respect to Y. That means we need to know the value of Y1 and Y2. Okay, for this figure, you don't have to actually determine the value of Y1 and Y2 because it starts from 0 until 3. Okay, so for R and H, okay, the R here is parallel to the y-axis. That means R will be R will be a substitution of Y. Okay, let's say we let here would be any value Y1, for example. So the distance between Y1 to the axis of rotation would be R equal to Y1 minus 0. So R can be equal to Y, because let's say if we drag it from the axis to here, this would be your another R. Okay, let's say we name it as R2. So this one is R2 and here is H2. So this is the value for Y2. The same goes here. For Y2 is going to be Y2 minus 0. That's how we're going to have the value for the radius. So from here we can see that R represents the changes in Y. That's why radius R equal to Y. And then height. Since our height is a horizontal line, that means we should actually calculate it by having the right function minus the left function. That means the right curve minus the line on the left. Okay. For y minus y squared minus y. Okay, simplifying, we will have h equal to 3y minus y squared. Okay, substitute the info that we the radius and height that had been determined in the formula. So V equal to 2 pi integrate from lower boundary to the upper boundary, which is from 0 to 3 here. Okay. And here R times H integrate with respect to Y. Okay. So expand these functions, okay, equations, and we have 3y squared minus y cubed. Integrate, it will be this one. Because here 3y cubed over 3, it will be y cubed only. Minus y power of 4 over 4. Substitute the value of the upper boundary minus the substitution of the lower boundary. Remember, write it even it is 0. And hence, we have the volume 27 over 2 pi unit cube. Okay. Next, we have this example. Okay, determine the volume of the solid produced when the region that bounded by the curve here x equal to y squared plus 1 and the line x equal to 7 minus y here is revolved about the line y equal to negative 1. Okay, first we need to determine where is the line y equal to negative 1. As the first step, you may find the intersection first so that you know where to draw the line y equal to negative 1. Okay, find the intersection points and we have y equal to negative 3 and 2. So these are the intersection points, negative 3 and 2. And hence, therefore, y equal to 5 might be around here then. Okay. This figure, we rotate here at line y equal to negative 5. Okay. So next, what do? We need to determine what is the radius and what is the height for this figure. Okay. Right from the axis of rotation or the line of rotation to the edge of the region bounded, this would be your radius. From this edge to the end of the shaded region, this would be your height. Okay. So as you can see, the height is horizontal. Therefore, V is equal to 2 pi integrate RH with respect to Y. Okay. This one should be the value from Y1 to Y2. So for this one, we will refer it to by the intersection points. That means from negative 3 to 2. Okay, let's determine the radius and height. Okay. The easiest part is for you to determine the height first. Okay, the height is horizontal, which means the functions on the left, on the right will subtract the functions on the left. So H is equal to the line. The line is actually 7 minus 5. Minus, remember to write bracket, okay, because it is negative here. Minus, and minus the curve, which is y squared plus 1. Okay, simplify, you will have H equal to 7 minus 1 is 6. 6 minus y minus y squared. This will be the H. How about R? This is the radius, okay. The radius will be the distance from this point to the axis of rotation. So, let's say we rename this as Y. So, the distance between here Y to the axis of rotation would be R equal to any value of Y here minus 5. Therefore, R is equal to Y plus 5. This is the distance. Okay. Let's say even you drag your R until this point, until this edge. Okay, this is your R. And this is your H. H will also be the same. The equation on the right minus the equation on the function on the left. And for R, let's say this one is Y1, this one is Y2. That means you still need to find the distance from here to, from Y2 to the axis of rotation, the line of rotation. That means how do we find the distance for a vertical line? Top minus bottom. Okay, top is the Y minus the line of rotation. Okay, as you can see, I've written here the radius R is equal to Y minus 5, which is Y plus 5, and the height is as written here to 6 minus Y squared. So next, just plug in all the info that we have in the formula. V equal to 2 pi integrate from negative 3 to 2, small value to the high value. R, y plus 5 times the h, 6 minus y squared, integrate with respect to y. Okay, you need to expand, multiply each term together, all together. Okay, remember all the terms, don't miss even one of the terms. Okay, after that, simplify. Okay, after you have simplified the equation, integrate. Okay, integrate the equation that you have obtained, and here it will be like as such. Okay, this one I have simplified. It should be actually 6y cubed over 3. So 3162. So negative 2y cubed. Okay. And then substitute the value of the upper boundary here, 2, minus the substitution of the lower boundary. Okay. And therefore, we have the volume equal to 375 over 2 pi unit cube. Okay. That's all for volume by cylindrical shells method, and it marks the end of this course. Okay. Try to grasp the a bit of actually an understanding on how to do volume by cylindrical shells method. Okay. Thank you.